We finished with the file inclusion in yesterday's video, and today we're going to start looking into the SSRF room. Maybe actually finish the room in one video, hopefully. I'm also going to start the machine over here, if there is a machine, and there is a machine. So let's jump right into it. In this room you learn what an SSRF means or is, what kind of impact they can have. You'll view some example SSRF attacks, how you can discover SSRF vulnerabilities, how to circumvent input rules, and then we have a practice for you against with to try your newfound skills. I'm gonna be completely honest, I haven't found many situations in SSRFs in my penetration tests, but I did find while I was doing bug bounty on some and cybersecurity research on some Google assets, I found a potential SSRF. I looked into it for about a week and then I decided to move forward. It might have been a situation where I would have been able to actually lead to a successful exploitation and maybe a successful and valid bug, but I decided not to pursue it. So it is what it is. What is an SSRF? SSRF stands for Server-Side Request Forgery. It's a vulnerability that allows a malicious user to cause the web server to make an additional or edited HTTP request to the resources of the attacker's choosing. Now, on the same line, I remember that a few days ago while I was doing a penetration test for a certain company, I had a situation where one of their calls, one of their requests was actually accessing an internal resource, and I decided that if I don't find anything worth putting into the pen test report, I will actually focus on that specific attack vector to try to see if I am able to get to a successful completion of an SSRF vulnerability. But I did manage to find a lot of vulnerabilities in that application, and my deadline approached, and that's why I decided not to actually pursue the SSRF path. But it was interesting because it was communicating with internal resources, so it was actually calling, it was sort of like underscore next underscore some parameter dot php and then 192 dot let's say 00, let's say 120.10.15, and it was a weird port 9000 something, and then it was calling an internal API. So that was that. It was interesting, but I decided not to pursue it, not to actually go down that rabbit hole. Types of server-side request forgery. There are two types of SSRF vulnerability. The first is a regular SSRF. So let's see. Are we recording? Again, trying to keep these videos around 20 minutes, but I haven't been very successful with the past, let's say, 3 or 4 videos, because yesterday's video was 35 minutes or so. The second is a blind SSRF vulnerability where an SSRF occurs but no information is returned to the attacker's screen. So the attacker actually doesn't see any meaningful output or meaningful activity in their screen based on the action they took to exploit or to test for the SSRF. What's the impact? A successful SSRF attack server-side request forgery. So you're forging a request on the server side. If you don't know what that means, so if you don't know what SSRF means, you're trying to put up the acronym in a logical way. You're forging a request on the server side. Access to unauthorized areas, like I've told you about my recent pen test, so I did not have external access to that internal resource, but using their external resource I was able to call an internal resource by a very specific parameter. Access to customer organizational data, ability to scale to internal networks. In this case, what they mean is to pivot inside the network, maybe move laterally until, let's say, you're in a network penetration testing scenario and your purpose is to obtain full administrative privileges on the entire network, which is an interesting scenario, most specifically for red teamers. Reveal authentication tokens and credentials, of course. And also, when you're testing for SSRFs, one interesting thing is to look for the metadata, which is in the situation where you're dealing with an AWS resource and also a Google Cloud Platform resource. Hopefully someday, if there is a lot of interest in these videos, I'm going to get into that situation. But like I said, and like I keep saying, that was Google Assistant. So, like I kept saying in previous videos, you need to share these videos because I don't get anything in return for actually recording these videos, for actually putting my time into recording these videos and sharing my experience. So, instead, if you want me to keep on doing these videos in my free time for free, share them so that they reach a lot of people and they get a lot of views. What does an SSRF stand for? Server side request forgery E. As opposed to a regular SSRF, what other type of SSRF there is? Click the view button, which will take you through some common SSRF examples, how to exploit them, and even a simulation to see if you can take advantage of an SSRF vulnerability using what you've learned. We're going to take you through some example SSRF attacks and explain how they work. At the end of the examples, you'll have to figure one out for yourself. The below example shows how the attacker can have complete control over the page request by the web server. The expected request is what the website .thm server is expecting to receive, with the section in red being the URL that the website will fetch for the information. So in this case, similar to the example that I've told you, the attacker can modify the area in red to an URL of their choice. Expected request. So in this case, we're dealing with a generic website, not even using a secure protocol. Website, a secure HTTP protocol, website.thm, stock URL. And in this case, it doesn't actually call an internal resource, but it calls maybe an external resource. We might not be able to access this external resource outside of this particular scenario, but who knows? This is context dependent. Hacker requests to this website requests, of course, so you're requesting to this website with this URL, and this website or server requests to this website or server. So it's basically two requests in one request. So hacker requests websites, website.thm, which requests the API, and then third API returns the result to website, which returns the result to the hacker. This is the expected outcome, of course. Now, the below example shows how an attacker can still reach the API with only having control over the path by utilizing directory traversal, which we've seen a lot of in previous videos. When website THM receives .. this is a message to move up a directory, which removes the stock portion of the request and turns the final item request into an API user. So in this case, hacker request, so the expected request is URL / item ID. Now hacker requests .. user, which goes to the API, which requests API stock, and instead of item ID goes up one level, / user. And then API server returns user data to website instead of stock information. So in this situation, you're dealing with a combination of SSRF and file inclusion vulnerability or directory traversal in this situation. And then finally, the website returns user data to the hacker. In this example, the attacker can control the server's subdomain to which the request is made. Take note of the payload ending in an X being used to stop the remaining path from being appended to the end of the attacker's URL and instead turns it into a parameter $X equals on the query string. So in this case, we're dealing with the same situation. Stock $server equals API and ID equals 123. In this situation, this is the expected request. However, the hacker requests server equals api.website.thm /API user and X equals and ID equals 123. Now in this situation, what the website or the web server, the website.thm actually does is to request to API website, so exactly what they requested here, API / user X equals and everything that's remaining. So in this case, equals is an empty parameter, and then in this situation is not actually an empty parameter, but the website actually fills in with .website thm blah 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 and ID equals 123. So again, request, another request, and the API server returns user data to the website instead of stock information, and then the website does the same thing to the users or to the hacker's browser. Going back to the original request, the attacker can instead force the web server to request a server of the attacker's choice. Now in this case, if they don't have, for example, if they don't have a well-established system of filters and whitelist, blacklist, accepted inputs, you're probably going to be able to access other resources outside of the scope, which is how you'll show impact when you present your report of the vulnerability. So in this case, instead of accessing HTTP API website.thm, you can access your own crafted URL with a malicious link. By doing so, we capture request headers that are sent to the attacker's specified domain, as I said. These headers could contain authentication credentials or API keys sent by website.thm that would normally authenticate to API website.thm. In this case, it would be not wise, so if we're dealing with an unsecured protocol like this one, if you're sending tokens and sensitive information in the URL, that's another vulnerability. So hacker requests this URL and then their own malicious or specified domain, and in this case the website does not actually make that request. So the website does not make the request to the API, of course. So this is they haven't actually made it very explicit, or it's something with my comprehension of it. So hacker requests their own domain instead of requesting the API website. So in this case, the API website is not even in question here. So there is no request to the API website, but there is a request to a hacker's own specified website. So the hacker asks the website to request whatever malicious link they want to request, and then the website gladly delivers data from hackerdomain.thm instead of API website revealing the API key. Now, that might not necessarily be the case, but in some situations, it actually is the case when you're being revealed with credentials. And instead of doing the request to, or additionally to doing the request to the hacker specified website, you could also request the server metadata from, if you're dealing with a situation when you have an AWS or a GCP situation. Using what you've learned, try changing the address in the browser below to force the web server to return data from this one. Copy. To make things easier, the server requesting bar at the bottom of the mock browser will show the URL that website DHM is requested. Instead of the API, we do that. So, item server. Or do we only need to do that? Not found. Using what you've learned, try changing the address in the browser to force the web server to return data from website flag ID equals 9. To make things easier, the server requesting bar at the bottom of the mock browser will show the URL the website.dhm is requesting. Not found. So in this case, server requesting what? It's requesting that, as you're seeing here. So we need to delete that. And we also need to delete this, I believe. Flag ID equals 9. There's something that I'm missing here. What if we only need to specify the flag equals 9? The issue is that they're adding this thing over there using what you've learned. So we need to somehow ignore whatever it's afterwards. We might use an n x equals something like that. So let's actually go back to the initial one, server.api. Item 4. Item 9 not found. Item 2. Server API. What if we do flag question mark ID equals 9 and gateway timeout? Again, server.website.thm, like that. So you had to ignore with and. In this case, we're just gonna copy like that. Let's see how we are dealing with the time. 20 minutes. Maybe we should leave the rest of the 3 of them, or let's just do the finding an SSRF and then leave the last 2 for the next video. Potential SSRF vulnerabilities can be spotted in web applications in many different ways. Here is an example of 4 common places to look. When a full URL is used in a parameter in the address bar. So when you're seeing a situation like this, do know that you may potentially be dealing with an SSRF. Or if you look into the source code and you can see the value, well, in this situation, if you look into the source code, you can see this value. Okay, another situation is when a partial URL, such as just a host name, in this case API, and as we've seen here as well, or perhaps only the path of the URL. Some of these examples are easier to exploit than others, and this is where a lot of trial and error will require to finding a working payload, the same as I did right now in this particular situation. If working with a blind SSRF where no output is reflected back to you, you will need to use an external HTTP logging tool to monitor requests. In this case, the burp suite such as requestbin.com, your own HTTP server, or burp suite collaborators client. What website can be used to catch HTTP requests from a web server? Requestbin.com. So I haven't ever used this one, but in any situation, we'll continue with task number 4 and number 5 in the next video.